Hello everyone, this is Gary Marr of Arizona State University. This screen captures from my IFT101 students, the online class. In the screen capture, I wanted to talk a little bit about the class, how I have it organized, the different components, some information about assignments, labs, and quizzes. I'm going to try to address some questions that have come up in the past when I've taught this class, and just kind of a welcome to get you started. There'll be other videos that I've created that'll go over lectures for each one of the modules. There's 7 modules altogether, but we'll get into those details here in just a second. Welcome to class, everyone. This is the 3rd time I put this class together, and I think that it's worked fairly well so far. For starters, the textbooks. You have a required textbook from Sprankle and Hubbard. It's a little pricey. It's the textbook chosen by ASU. It's a great book in terms of going over logic modeling for a whole bunch of languages. It's not specifically written for Python, which is why the Python book is also in our book list, but it's a good book in terms of introducing structured programming and procedural programming. Now, what will happen with this particular textbook is it will relate directly to the assignments that we have, but not to the labs as much. But again, the Sprankle-Hubbard book has been written for all programming languages, more or less, Python being one of them. But when it comes to the labs, what you'll probably work more with is the Severance book, which is free, the PBOK book, which is a link on the internet, which is also free, or any Python reference you can get your hands on. What I'm going to try to do in each one of my video lectures is not only go over the material that's in Sprankle and Hubbard, but also relate it back to the Python that's going to be required for our labs. The quizzes will be a combination of the Sprankle-Hubbard book and Python. It'll be primarily short answer questions. There will be a couple of essay questions at the end, but primarily short answer questions, true, false, multiple choice. The class tends to be fairly large. I have a grader or graders helping me with your assignments and labs, and I'll do all the grading for the quizzes. I will create lectures that'll basically be PowerPoints that I will go through in a video format also. I'm trying to accommodate as many learning styles as I can here. Some people can read a textbook and be fine. Some people can read a textbook and do the examples and be fine. Some people like to be talked through it. Some people like to watch a video through it. There'll be some repetition here. I mean, you're going to find that I'm going to cover in the PowerPoints a lot of the information that's covered in Sprankle. Sometimes there'll be some new information there as I try to connect Sprankle to the PowerPoint portion of our class. But if you start seeing a lot of the stuff repeated, it's just because I'm trying to accommodate different learning styles here. I try to put a lot of web references and videos in here that I think will be helpful. Whether or not you want to watch them is kind of up to you. There's some that are definitely required, some which I've labeled as optional. They're all going to be helpful in terms of getting a better grade in the class and getting through the assignments and the labs. The class is divided into 7 Canvas modules. Each module has an assignment and a lab, and then there'll be 4 quizzes spread out the entire class. None of these quizzes, quote unquote, are comprehensive, but obviously they will draw on material that you've learned in previous modules. The modules are set up around weeks. Week 1, Module 1, Week 2, Module 2, etc. This is kind of a graphical overview, which more or less happens here. There's been some confusion in the past in terms of how the Hubbard book relates, Sprankle-Hubbard book relates to the the Python section of the class. And essentially, what happens here is, again, Sprankle-Hubbard is a general textbook on programming, and it could be used for a whole number of programming languages. You guys will have other programming languages you'll take before you finish your coursework at ASU, and you might go back and look at this book, get some help from it, in the future. But what I'm going to try to do here, since Python is a great language to get started on, is I'm going to take and map back the Python to topics covered in Sprankle and Hubbard to help you give you a good start with programming. If you have programming experience already, then obviously you're going to get through those materials a lot quicker. If you don't have a lot of programming experience, that's fine. That's not a requirement for taking this class. You'll have more questions possibly. You may have to watch a few more videos and go to a few more web pages, but that should be fine. Use the PowerPoints as a way of identifying the key points that I plan on introducing in the class that will show up also in assignments and quizzes. And the PowerPoints for me are a way to make sure that I deliver all the material I think is the most relevant for this class. So again, don't be put off if you think there's repetition there, because there is. But what I've done is I've tried to boil down the important topics in the textbook into those PowerPoints. And then finally, all of this information gets blended into assignments, labs, and quizzes. Again, assignments more from Sprinkle, okay, labs more from the Python information, Python textbook materials, and there is class resources that I put inside Canvas that will give you some links to various Python resources. And that's all going to go into our testing assessments. The way that Sprinkle and Hubbard have introduced the materials, again, because it's a general programming book, is they tend to talk about algorithms, pseudocode, flowcharts, all of which those three are just logical, are ways of creating logic models. The algorithm is the simplest logic model. You can think of this as like someone giving you some instructions to get down to ASU. They tend to be informal, but they tend to be stepwise. Start at the top, work towards the bottom. If you follow the steps, you're successful. A flowchart is a graphical representation of that logic model, so that algorithm now becomes a set of organized symbols connected by arrows. Pseudocode is very much like an algorithm, except that it's structured formatting-wise, indentations, tabs, keywords, so it looks more like programming code. It's fairly easy to take pseudocode and convert it to Python. Other languages, not as easy, but essentially pseudocode is the closest thing to programming code. It'll be very close to Python. And in the text or in the assignments, you'll find sometimes I don't really care if you give me algorithms or Python, but there'll be a couple situations where I may specifically ask for an algorithm or ask for pseudocode. If you have any questions in this, send me a Canvas email. Post your questions to the discussion board. I'm going to talk about getting help and questions in a future PowerPoint slide here in just a second. Again, Sprinkle and Hubbard is written as a general resource for all programming languages. Java, JavaScript, you name it. What we'll be including in this class is obviously a pretty healthy introduction to logic models. That's our algorithms, pseudocode, and flowcharts. We'll also be working with structured programming, procedural programming. We'll do some array and file processing. We will not have any object-oriented programming in this class. It's in the textbook, but you'll have some future classes where you'll be introduced to that concept. Python is being used to implement the logic models that we create in the readings of Sprinkle and Hubbard, or implementing the flowcharts and pseudocode that are created in the textbook. So there's a process here. We start off with an algorithm, which is a very rough plan for how logic was going to work in our program. We move it to a more formal model in pseudocode or flowchart. They typically tend to be one or the other. And then finally we implement that logic model into a real live running program. And then that's where we use Python. Common questions. Can you work ahead? Yes. For assignments and labs. Quizzes, no. Quizzes are scheduled to be done over a block of time, a couple days. The reason we do that is for grading consistency. You can work ahead in quizzes and labs. You may not see them graded early. They may be graded with everybody else's. Again, for grading consistency, it's a lot easier for us to be consistent in our grading when we do them all together. The quizzes are definitely going to have a set time. And if you're planning on trying to get the class done in a couple days, well, that's fine, but you're going to still be taking the quizzes on the scheduled dates. Books necessary. Sprinkle, Hubbard, yes, there's a lot of material there that's going to go into assignments and also the quiz questions. As far as Python goes, the Severance book is offered for free online. There's also videos that go with the Severance textbook. There's a whole bunch of free Python resources out there. One of them is the PyBach site, which has a lot of good stuff, more than what we'll ever use. There's a lot of other sites also. So what you do in the Python side is pretty cheap. The Sprinkle Hubbard book is a little pricey, but again, it is a general textbook for all programming languages. Class dates are January 11th to March 2nd. If you have a question, that's general, question with the assignment, clarification, something you're not sure about, but you think it's something everybody would have a question with, post it to the discussion board. There's a discussion board area for every module. So if this happens to be an assignment with module 3, then post it in question to discussion board 3. You might have another student that will help you clarify it. They may chime in and say, I'm having the same problem. I try to monitor the discussion boards daily, but if you want a quickest answer to a problem or question you have, send me a Canvas email. Those always get my top priority. And as far as the pecking order goes, it's going to be Canvas emails are highest priority, discussions boards are second. If you can't get through in my Canvas email, I also have an ASU email, which you can find in the syllabus. Don't be afraid to ask questions. I mean, this class has been taught enough times so that hopefully most of the confusion has been exercised from it, so that you're not going to have too many questions. But depending on how you read it or how you interpret something that's been put on the page, there could be a question. Just don't be afraid to ask it. It's fine. Again, this is the pecking order or the priority of how I'm going to address your questions and give you help. So keep this in mind. I wouldn't try, the phone doesn't really work very well. Usually there's all kinds of time issues, time differences. Usually we can address most problems with email, and if we can't, we can always use something like a Zoom session to walk through some code or some problem that you're having. But I found in the past, this class, most of the questions can be addressed with email and maybe for further clarification of a problem a student is having. I look forward to working with you guys. Like I said, this is a class that I've taught for several times. It's a class that I've taught other institutions for many, many years. It's a fun class for me. I love programming. It's a little trying. It can be a little confusing at times. We're basically asking a machine to do something for us. And what you're going to find very early here is that if you don't already know this from doing programming in other classes, is that computers will do everything you tell them to do exactly the way you tell them to do it. And that seems like that's fairly straightforward, but the problem is the human brain is so much more sophisticated than that. There's a lot of things that our brain helps us with that we cannot assume the computer to do, and if we tell it to do the wrong thing, there's nothing to stop it from doing that also. So it can be a little bit challenging initially. It takes almost a change in thinking to be a successful programmer. You have to think like the machine, which means for many of us we have to dumb ourselves down. Machines don't learn, they don't reason, they don't have common sense. So all those factors kind of come into play when you decide to write code. But again, I'm looking forward to working with all of you. If you have any questions, please let me know. Thank you.